In this section, we'll learn about Corona materials and maps, and for the first few lessons, we'll be covering the most important and the most frequently used materials in Corona, which is the Corona MTL or Corona material. We'll be using this shader ball scene from masteringcgi.com.au. I have converted the scene to Corona and adjusted it a bit to make it more suitable for this lesson. Press M to open up the material editor. In the material browser section under materials and Corona, we can see all the Corona materials, including Corona hair material, Corona skin material, Corona light material, and so on. We are interested in this Corona MTL, which is the Uber shader in Corona. Also under maps, you notice we have a bunch of specific Corona maps as well. Also, Corona supports all the 3ds Max's procedural maps. For now, let's drag a Corona MTL or Corona material to the active view. And you can simply also right click in the active view and access Corona materials and maps. And let me just double click on it to see its parameters. Corona material is the most powerful and versatile material in Corona, and it is capable of producing almost all types of real-world shaders and materials, from water to plastic, glass, wood, concrete, metals, and much more. Let me just double click on the material preview so we can see a bigger preview. We need to assign the material to the shader ball. Simply select the shader ball, right click on the material, and assign it to the selection. If you take a look at the Corona material, you notice it has different sections: diffuse, reflection, refraction, opacity, displacement, volumetrics and SSS, bump, and so on. Combining these components and parameters makes it possible to create almost any shader using this material. In this lesson, we talk about the diffuse section of the Corona material. So let's run the interactive rendering and see what we get. The first parameter that we have is the diffuse color. This is the base color of your material. You can choose a simple color or use a map. If you are creating, for example, a red plastic shader, you would choose red as your diffuse color. Or if you are creating a wood shader, you would use your wood texture as your diffuse color and connect it to this parameter. So you can choose any color as the diffuse color, and this way control the very base color of the material. Let's try some colors here. Or if you click on this button, you can choose a map as your diffuse color. So let's click, and you can use Max's procedural maps or use any other bitmap. In this case, let's select bitmap from the general category and choose Wood Parquet 02 as our map. We just need to select the map and set its styling to 0.1 and 0.1 on U and V. And now it appears on our shader as our diffuse color or base color. Also in the active view, you can see now a bitmap node containing our wood texture has been connected to the diffuse map. Let's for now keep this texture, and instead of this mid-gray color, use a greenish color. Another interesting thing that you can do is to mix and match between your diffuse color and your diffuse map. Right now we have this green color as the diffuse color and this wood texture as a diffuse map. If you come down to the maps rollout of the material, you can see for a diffuse we have a map defined, but we also have a number which says 100. And this is the magic number to be used if you wish to mix between your diffuse map and diffuse color. For example, if you want to tint your diffuse texture with a specific color. Right now it's set to 100%, so only the texture will be used. If I set this number to 0, only the color will be used, in this case this green color, and if set to 50%, 50% of the texture and 50% of the color will be used. Let's set it back to 100, which is normally the value that you would want. we have this diffuse level parameter that acts as a multiplier for the diffuse color or the diffuse texture, if you have defined one, obviously. So if it's set to 1, you will be using 100% of the defined color or texture RGB values. And if I start to decrease the value, you notice we get darker and darker diffuse colors. Let's delete the map for the time being. You can simply right click on the map slot and choose clear, or simply select the node in the active view and press delete on your keyboard. And instead of this green color, use the default mid-gray value. The value should be set to 128, which is the default color. Before moving on, I want to briefly talk about the importance of not using too white, or better to say too bright diffuse colors. We have a concept called albedo, which in the realm of shaders and materials indicates the overall brightness of the object. Albedo is the reflecting power of a material. In Corona, it is the sum of materials' diffuse, reflective, refractive, and translucent components. Let's click on the diffuse color and open up the color selection. If we consider the value of 0 as pure black and 255 as pure white, the whitest of whites in real world probably will be represented by a value like 220 or 225, like a very, very white snow. But for a normal white, for something like a white interior wall or a white cabinet in the kitchen, you don't need to increase this value beyond 180 or 185 at most. Using very bright values as your diffuse color, especially for large diffuse surfaces like an interior wall, will make the render to be much slower, much noisier, completely washed out, and unrealistic. So at all costs, avoid using higher values than 180 or 185 in most cases. For special surfaces, as I mentioned, you can approach 200, 210, or 220. There is a way in Corona to detect if you have used a wrong diffuse color, a diffuse color that is just too white and unrealistic. If you go to Render Elements tab of the render settings, there is a render element called C Shading Albedo. Let's just add this and change the diffuse color to 255. And start the render. First of all, you notice the surface is just way too white and reflects all the incoming lights diffusely. Now, if we go to the C Shading Albedo, we get this red warning color that tells us that the diffuse value for this material is just way too high and will cause problems in terms of realism and render efficiency. But if I start decreasing the value closer to 200, that red color turns into a light gray color that tells us we are good to go. And obviously, if you use lower values, that color will become darker gray. Let's stop the render and go to 128 mid-gray as our diffuse color. Under the diffuse section, we have these translucency values, which allows you to simulate translucent surfaces that allows light rays to go through them. Stuff like paper or leaves, for example. If I just hide this shader ball for a moment and create a box and add a Corona light right inside that box, and also assign our Corona material to that box, and run the interactive rendering again, you notice with the translucency set to 0, the surface won't allow the light rays to pass through it. We don't think there is any light inside that box. But if we increase the translucency fraction value to 0.3, now we see how the surface is glowing, indicating there is a light inside the box. And if we increase the translucency fraction value to, let's say, 0.5, you notice that effect gets extenuated. And using the color value, you can control the color of the translucency, or what color the light rays will turn into when translucency is happening. For example, if you use this effect to create a leaf material, this color is going to be a green, or a leaf texture that is green. And this feature can be very useful for simulating very thin translucent materials I mentioned, like leaf or paper. If you go to the Corona material library from the Corona menu up here and go to the nature section, we can assign this leaf cherry material to our box object. And just to see how to use this translucency parameter, let's also load that leaf material in the active view and run the render. You notice here they have used this green leaf texture as the translucency color, and translucency fraction is set to 0.35. And that's why we get this realistic leaf material. If the translucency fraction value is set to 0, we get this solid, lifeless, non-translucent leaf material. For now, let's assign our original material to the box and delete this leaf material. Set the translucency to 0, delete the box, delete the light, and unhide the shader bulb. Another thing that translucency does is to control how much volumetric scattering we want in the material. Don't confuse this volumetric scattering term here with what we learned about volumetric scattering in our lighting section. They are kind of related to each other, but this is talking about the volumetric scattering, which is a feature of the Corona material. Down here in the volumetric and SSS section, we have two subsurface scattering modes, volumetric scattering and SSS. We talk extensively about these two modes later on in this section, but if we choose volumetric scattering as our subsurface scattering mode, we can change the absorption color to, let's say, pink, distance to 8 centimeters, and scattering color to green. We notice nothing has changed. In order to allow this volumetric scattering through, we need to increase our translucency fraction as well. So this is like a mix value between the diffuse contribution and the volumetric scattering. So if I set my diffuse color to blue, when the translucency is set to 0, we only get a diffuse color. And when set to, let's say, 0.5, we get a combination of the diffuse and volumetric scattering components. And when set to 1, the diffuse component is gone and we only get volumetric scattering. Perfect. In this lesson, we learned about the diffuse component of the Corona material. See you in the next lesson.